million train cars move throughout the world's fifth largest economy, California, every year. About $70 billion worth of freight, or 20,000 train cars a day. These 14 sections of railroad track allow these trains to cross the California border, carrying oil, iron ore, or like these two Union Pacific Express trains, shipping containers. These two trains leave Southern California each day and arrive 3 days later in the Chicago rail yard, carrying hundreds of containers from the port of Los Angeles. They'll unload, then reload with new freight and head back to California, completing a critical connection between the manufacturing centers around the Great Lakes and the busy LA ports. The problem is that in just a few years, these trains won't be allowed back into California. Starting in 2030, California passed legislation that will ban locomotives over 23 years old, targeting those built before 2007 because they run on diesel. And by 2035, all new locomotive engines must be zero emission, revolutionizing the rail industry. The upfront impact to the rail industry is enormous. Because the median age of the entire locomotive fleet, 37,528 locomotives right now, is 23.8 years. That means in 6 years, almost half of these locomotives will not be allowed to enter California. And because California is a gateway for Asian imports and exports, most locomotive engines cross into the state at some point each year. U.S. freight rail carries more than a quarter of all U.S. freight cargo. So this has wide-ranging impacts and opens up some interesting questions and opportunities if you're so inclined. Let's say you're a railroad CEO and you're currently in the market to buy some new locomotives. One of the first questions you'd ask is, can California do this? Ban diesel engines? And the answer is yes. Because unlike the other 49 states, California has a truly special power. Back in the 60s, California's air quality was among the worst in the world, putting the state at the forefront of the emerging environmental movement. 1963, the U.S. federal government signs into law the Clean Air Act. This gives the federal government the right to set nationwide air and pollution standards that all states would have to follow. We're talking car emission standards, chemicals associated with ozone holes, making utilities manage the emissions that cause acid rain, on and on. This was all federal level stuff. But amendments to the 1970 version of the Clean Air Act changed this line to this line. All states, except California, are prevented from setting standards that are more strict than the federal standards. Why does that matter? Because now when California says, if you want to sell something here in California, it has to meet our standards. Those standards become the de facto national standards. California set the first tailpipe emission standards, was the force behind cars all having catalytic converters, which in turn caused lead to be taken out of gasoline, forced cars to have onboard diagnostic computers. The list goes on. Plenty of people detest this power, challenging it in court multiple times, but it's still here, making it likely that California's law will ban diesel locomotives, completely revolutionizing the rail industry. Replacing these engines will cost tens of billions of dollars because the locomotive can't just be swapped out at the California border. The areas for a train to stop and make changes to cars or locomotives are few and far between. It's not a highway where you can just pull over to the side of the road. There isn't a rail yard at every train crossing into California. A new diesel locomotive costs about $3.5 million, generates 4,500 horsepower, and can run for thousands of miles before needing fuel. The leading manufacturers of these diesel engines are Westinghouse Air Brake and Progress Rail, a Caterpillar company, in second. Both of these companies are racing to create replacement locomotives that can hit the benchmarks of their existing diesel engines while also being zero emission. Two technologies are on the table: batteries and hydrogen. For batteries, range and cost are the primary issues compared to today's diesel engines. Even for these companies, their cutting-edge battery-powered models can run in the absolute best-case scenario up to 800 miles before needing to be charged. Compare that to diesel-fueled engines that can run for thousands of miles before refuel, and the amount of time it would take to charge would take hours instead of the minutes it takes to fill a diesel tank. On the plus side, regenerative braking can help expedite the charging process. This is when the force generated from slowing or stopping a very heavy train is channeled to a generator inside the train that takes that force, turns it into electricity, and puts it back into the train's battery. Because of the limited range and the time it will take to charge, if battery-powered engines come into full effect, it's likely that train cars that carry batteries will come onto the market, kind of like a portable battery used to charge a phone. So while these train engines are not there yet on range or charging, we've already done this with electric vehicles. These pain points are probably solvable, but what would a battery-powered engine cost? The companies building these things don't love to talk about how much they cost, but we do have a few clues. Last year, Union Pacific announced it was buying 20 small battery-powered locomotives for about $90 million. That's nearly $4.5 million per engine. These engines have very small batteries, 1/3 the size of what most locomotives will need. Add that all up, and the math says a battery-powered engine is at least $7.5 million, more than twice as expensive as a diesel engine. And functionally, it's still not comparable to a diesel engine in power or range. If you wanted a battery-powered engine to pull a train from Los Angeles to Denver, a more likely number is closer to 10 million. Hydrogen-powered engines. Hydrogen has been a long-shot fuel source for decades, but these engines are under serious development. Westinghouse Airbrake is working with General Motors to get this to work, and there is a real-world hydrogen train running in Germany. The allure is that a hydrogen fuel cell train can run fully loaded for thousands of miles with the only emission being a little bit of water, a true clean technology. At the heart of a hydrogen train is the fuel cell, which converts hydrogen into electricity. Hydrogen gas meets oxygen in the fuel cell, sparking a reaction that generates electricity and produces water as a byproduct. The big challenge is producing the fuel, hydrogen gas. Most of it comes from electrolysis, using electricity to split water into hydrogen and oxygen. This requires a lot of electricity. Ideally, we use electricity from renewable sources like solar, wind, or nuclear to make it emissions-free. If we use fossil fuels, it's kind of back to square one. And even if we have the hydrogen gas problem figured out, there are other challenges around storing it, transporting it, how hydrogen interacts with metal. Yet despite these challenges, a hydrogen-powered train, the Kareidia Islet in Germany, runs daily, proving it is possible to power a train with hydrogen. But this train, hauling maybe 15 passenger cars, is tiny compared to what is required for hauling miles-long freight trains over vast distances. Railroad and locomotive manufacturers have talked at length about hydrogen, and they all tend to agree that it's in the future, but without a major breakthrough, not within 5 or even 10 years. So for railroads to get to zero emissions, railroads and the companies that make locomotive engines are saying batteries are up. Wabtec has its flex drive technology and Progress Rail has its Joule technology. However, after buying General Electric's railroad division in 2018, Wabtec is the undisputed leader in locomotive engines for the North American market. Progress Rail even filed a lawsuit in 2023 against the company in Delaware court, accusing the company of being a monopoly. They are also the only company with a battery-powered locomotive about to enter service in Australia. The Roy Hill Railway is a rail line dedicated entirely to hauling iron ore from the Roy Hill mine to Port Hedland. Running 344 kilometers in Western Australia, it's hot, averaging 100 degrees Fahrenheit in the summer. Great for testing how batteries will hold up under load and heat. And then there's a long downhill leg from the mine that allows the train to use regenerative braking from a heavy, fully loaded train on a downhill slope. But this is only an interesting project right now. It's not even running yet, which highlights an irritating problem for the railroads, but a potential and quite lucrative windfall for the companies that make locomotives. Railroads will need to replace engines that are over 23 years old within the next 6 years, and by 2035, they will need to be fully zero emission. Yet there is no clear technology for them to buy right now. What technology is going to stick? For now, they're still just upgrading older engines, sending them to Wabtec or Caterpillar for retrofitting with newer diesel technology and putting them back into service, waiting to see what happens over the next few years as zero-emission technology progresses. The engine makers get a big windfall. First, railroads are upgrading their existing engines to new, better diesel technology, and then are being forced to replace huge swaths of their fleet much sooner than they otherwise would. Of the 15,000 plus engines that would need to be replaced with zero-emission technology, maybe a few thousand of them would have been replaced in the next 10 years if this California legislation didn't come up. 15,000 engines at a $7.5 million per engine price is $112 billion. And that, what is 11 times the annual revenue of Wabtec, is a conservative number. The scale of this build-out spawns some additional questions. Where will all the material for the electrification of trains come from? The batteries in one electric locomotive will be about the equivalent to all the batteries in 120 Tesla Model 3s. But because an EV owner doesn't drain their car batteries every day or even every week, a train's batteries will be drawn down and charged far more often, making the impact to the electrical grid closer to 6 or 7 million additional Teslas on the road, more than 3 times the number of cars Tesla sold last year. Copper to make the electric engines is also a question. Taking hundreds more pounds of copper to build these diesel versions, these trains are a brand new, very hungry entrant in the competition for resources critical to the electrification of the world. Lithium and rare earth metals for batteries, these supply chains have been tight for years now. We probably won't get a final ruling on California's legislation before the end of the year, but if the markets are predictive, then the move in the stock of companies like Wabtec indicate that the ruling is likely to go through. One thing about the energy transition is certain. It's creating big opportunities for some, in this case, the companies that make locomotive engines, and big headaches for others. The railroads are fighting this with everything they have.